Hey everyone, hopefully you can hear me. I think there's a chat if all panelists and attendees. If you can't hear me, okay, let me know. I see Ryan's joining. That's good.
Howdy. That's a very serious microphone you got.
I can't hear you. So let's figure out what I've done terrible to my audio. Want to try talking again?
Could be me too.
Nah, it's me. It's Pulse Audio.
Classic. I've just been command line editing my webcam config because apparently that's how you do it in Linux. I'm feeling.
I was lucky enough that I just, it just works for me.
Oh, it just worked. It's just that none of the like auto scaling stuff works, so it's like oversaturated as heck. And
I have never messed with that, but it's probably something I should. We've got question and answers. No, I can hear you. Okay, cool. I'll
we've got
open up
participants too.
an open invite to any of the embedded working group folks. If you want to step up and be a part of the conversation, you're welcome to just let me know and I'll nominate you as a panelist. Okay. So
that question though.
Yeah, I'm getting some great questions. Yeah, as panelists, we can see questions. So the JPster asks, why bother with Rust when we have C++? Excellent question. Let's pack up and go home. Because I've tried to learn C++ for the last 10 years and have been unsuccessful the entire time. Done. Answered live.
Hey, that's a cool feature.
Yeah. So for anyone who didn't follow me on Twitter, the whole point of this is the tooling that we're going to be using for Oxidize 1K later in the week. And I wanted to have a chance to play around with it. So Ryan was brave enough to volunteer to help me test it out for the first time. We've used Zoom for a bunch of other things, but we haven't used the webinar feature. So this is a recently purchased webinar license. Jay Peaster is asking if it can have multiple video streams or just a single feed. I know on my screen I get the chance to switch between gallery view and speaker view. I think you can too, but I've also never been a participant, so let me know how that goes.
Yeah, I've never tried this from the other side. This is also the longest possible like distance video call I think we could achieve.
We are literally 12 hours apart in terms of time zones, so I think
sides
you are.
Of the planet.
Yeah, let me invite and get the copy URL. And let me tweet about this because, let's do a load test. So I'll leak. So far, we've sold nearly 200 tickets to Oxidize 1K. So it's going to be, it's looking like we're trending toward, or I think we sold like 165, 170, but I haven't checked since we announced speakers. So it's likely we'll probably have 250 or so people in the Oxidize 1K event.
It's a really good reminder that I should go and get a ticket to Oxidize 1K.
They're going to be on sale until probably noon Berlin time before the event because we need to do one final export from our ticket provider into Zoom just so we have it. So we'll probably cut off. Then. Selected speakers do not need to buy tickets. Speakers are gifted a ticket for free.
It's dangerous to say stuff like that,
Yeah. Well, JP's asking, but he's asking as a speaker. So I think at this point he's just having too much fun with the Q&A.
So the email that I put into the Oxidized billing form is going to be the one that my Zoom is going to expect, or are you going to send out like a key to all the registered people?
So for the actual event, we'll, what you put in the ticket form is what we're going to email. So we'll do one batch import into Zoom that says, hey, these are all of the participants. They've already paid. Invite them. And it'll send out a single-use email to everyone. We also expect people to not have. We'll probably start importing those through the week, just so we know hopefully people can get there early. Yeah, someone's saying the Q&A doesn't show all questions until you answer them. Yeah, we have there's options to turn off chat entirely, and I guess this is just so you can't have people like spamming there. The idea, or for Oxidized 1K, we'll probably have a second person, we'll probably have multiple people from Ferris sitting as moderators, but not with video or audio on, just so they can answer questions and things like that and raise them up. Although we don't plan to have speaker Q&A for Oxidized 1K, so
Good choice.
yeah, well, we may end up having Q&A during the breaks. So we're going to have like either a 5 or a 15-minute break between every talk. We have a couple things planned for some of those 15-minute breaks that we haven't announced yet. But we will mostly just have break, probably with a logo splash screen up so people can go and get drinks and use the bathroom and stuff like that. But yeah, we also might answer Q&A if there's a bunch of Q&A items. I'll probably leave it enabled and just ignore it if it's not going well. But if people are asking good questions, you'll probably see my face duck in on some of those 15-minute breaks and talking about things.
Have you thought of putting out a Google Calendar or something for those of us that are extremely not in your time zone?
The Zoom invite will have a Google Calendar invite in it. The email you should have gotten should have come with a Google Calendar invite. I think also when you buy the ticket, it sends you a calendar invite. I know because for some reason when people accept that, that goes to the Oxidized email account. So I've been seeing the I'd say like 10 or 15 people have accepted that calendar invite, but we get this person has accepted your meeting email response from some providers, I guess. So if you buy a ticket, it will send you a calendar invite, I believe.
I guess more specifically the like talks in the calendar, but I guess everything's pretty quick anyway.
No, we hadn't thought about that. I don't use a lot of Google Calendar for like open events and things like that. But yeah, I think it'd be reasonable. You should probably
It's
just have
something
like
we've done a couple times.
Okay.
At least kind of worth it.
Yeah, we'll look into it. I'm not. I don't think we have a Google account for Ferris. So I suppose we can set that up. We're also doing this on super short notice with super short staffing. So basically, this has become like minimum viable conference.
Yeah. Oh,
okay.
It's gonna be a time.
It's gonna be something. Like we definitely went into it knowing that it was gonna be something. It really was. I'll be very honest. I woke up that morning, had the idea when I woke up and was drinking coffee, texted Florian at about 9 a.m. and by about 5 p.m. we had everything announced. So it really was about 9 hours and 45 minutes from a crazy idea. And I literally texted Florian, "Hey, I had a crazy idea. Can you jump on the phone?" At about 9 something. And by 5 p.m. we had announced Oxidized 1K. So it's really been kind of a ridiculous turnaround. And we've been really lucky that Florian's done a bunch of conferences before, so he very much knows what he's doing. We've done Oxidized once before, and we were in the middle of setting up everything for Oxidized Prime at the moment. So everything was kind of fresh and set up. So we were able to just kind of creatively copy and paste and have enough tooling necessary. And we'd also been looking at things like Zoom's webinar features for some of the trainings that we're planning on doing in the future. So it really was like we realized we had all the parts in the box, and it was like, okay, yeah, I actually think I think it would be reasonable to do that. So JP's asking for slides. So let me pull up my let me pull up some of my previous talk slides just so we can see them. Find something that I've gotten a security alert for, because whatever I use is a let me go full Saturday. The static site generator that I use, I think, has some deprecated JavaScript dependency in it, and every time I open up the repo, it complains about it. So let me move this to another desktop and close other tabs, and let me share my desktop. Let's just share this one. Well, let's share the whole desktop. Cool. So that's shared.
Wow, that really suddenly takes control of your machine and full screens it.
yeah. Was it F11? F11. Cool. So now we have slides. I've still got like a little window where I can see all the presenters, but also the slides. Hopefully people can play around with the I can't see the chat anymore, which is interesting, but I still have the QA as a broken out window. So this is a talk that I gave at it was a C++ conference. It probably Meeting Embedded. Yeah, Meeting Embedded last year, where it was basically me going to a C++ conference talking about how often people use C and structure packing as a like communication protocol for things, because it seems easy. It's easier than setting up proto buffs or things like that. And you're like, I can just mem copy the struct, right? And the answer is everything is cursed and everything doesn't work on different platforms and it's not portable and things are terrible when you're talking between like different endianness or different integer sizes and things like that. And how things can sort of work until you change one thing. Like if you have f short enums, which like scales the size of your enum based on the number of members, when you go from literally like 255 members in an enum to the 256, all of a sudden now it's a 2-byte message, which means if you have one device with the old code, then it's going to be doing everything wrong and you're going to get garbage everywhere, which is literally a bug that has bitten me on production devices before. So like most of the, like I say most of these things, they're almost all entirely things that I've run into in production. And I just talk about different things and what Rust is because it was a C++ conference, and how cool Serde is and how it breaks people's brain that it works on embedded and it's actually pretty efficient if you use something like SS Marshall or Postcard. But this is a room full of Rust people, so I don't particularly need to give the
Yeah, I think we're sold.
yeah, I think everyone's sold in this room. You've all probably bought tickets. So I'm reading down some of the comments. Full screen takeover is creepy. As a viewer, you can switch between speaker and slides. From the chat, double click on the blue arrow. Okay.
Yeah, I
Transitions are a
guess
little odd.
transitions. They'll be getting video encoded, right? So that'll be a bit strange.
Yeah, that's the other thing. I'll probably do this in a future. I'm going to do another one of these chats tomorrow. I think it's actually going to be with Tony Arcieri from, or Bascule on. He's fairly active. He's actually going to be one of our speakers, but we're going to talk about not the stuff that he's speaking about, just not to ruin the talk. I need to move my talks back up to my second monitor. Yeah, I mean, my laptop doesn't have wonderful graphics performance, so I get screen tearing on my screen. So if you were seeing screen tearing, that's probably just my laptop being terrible, not necessarily Zoom. The other thing I do want to try is we'll have some speakers who are going to be pre-recording their talks. So probably in my talk with Tony tomorrow, I'm probably going to try pulling up a video. I need to go download some like royalty-free videos or something like that and put them up. The slides are available online. Let me link to them. It's on the Fair Systems GitHub page. If you look for embedded Rust and Serde. For Fair Systems, most of the time when we talk, we tend to put our slides as a static website on github.com/fairsystems. I will go pull up a link to this specific talk, though.
Do you have a plan for propagating these for Oxidize 1K as well? Because it's quite nice if you're plugged in remotely to be able to pull stuff up, like actually as you're watching it.
We haven't in the past. We've typically asked speakers to give us a PDF of their slides, and some of them have and some of them haven't. I think we only got like 4 or 5 back
tricky.
from Oxidize. Yeah. We can't ask people. Yeah, we will ask people because that's a good point for people following along at home. For that specific talk, so that Embedded Rust and Saturday, I think it was recorded, but I haven't seen it posted yet. I think they're still chewing through their videos. They had a lot of talks. It was part of Meeting CPP, which is a much larger conference, and Meeting Embedded was like a birds of the feather kind of day beforehand. So they had one day of talks tied with that, and I don't think they've published all of the Meeting Embedded talks. That was also here in Berlin. So, but yeah, let me pull up the paper you had. So the goal for this was, so I've also been wanting, like JP said, people are bored and they think they should run a podcast. But they probably shouldn't. But I'm going to keep plugging through like we should run a podcast because there's been a bunch of people that I've just wanted to talk to. And I've been looking for an excuse, and testing out tooling is always a good excuse to get people online. And we managed to find 16 people to come watch us, so that's not terrible. So let's go ahead And oh, I think I only responded to one people, all panelists and attendees. Let me repaste that just so everyone can see, I guess. That's a link to the slides. I don't think there's a video out yet, but it'd be on the meeting C++ YouTube page once it is posted, but I checked a couple weeks ago and it wasn't there. It says you want to answer the question live. Do you need to like mark that as answered? I think you said, it says you would like to answer the question live.
So I clicked the "this has been answered" button.
Huh.
And now there's a done option.
There's a what?
Now it's come up with, yeah, you'd like to answer the question live, and I've got a little done button.
Maybe it's because I'm the admin, because I just pressed it and it said done, but I wonder if it was just because you're not the admin for this, or you're not a host.
I can still push done though.
Yeah, interesting that it's a two-step process for you.
Yeah, I don't know why.
Yeah. So I invited Ryan on to come and talk about something that he was interested in, particularly something that I don't have a lot of idea about because I like learning new things and hearing from people. So I kind of wanted to give Ryan a soapbox to either talk about or use me as a rubber duck for something he had in mind. I know he has prepared a couple things that he wanted to talk about, so I'm gonna hand it over to you to talk about whatever you want to talk about first, and we'll talk about it as long as there's interest. And I'll keep an eye on the Q&A. So if people have questions, go ahead and throw those up in the Q&A feature, and yeah, we'll pick something to talk about. So you want to introduce yourself? Well, okay, I'll probably introduce myself first. So I'm James from Ferris Systems. Ferris runs Oxidize, part of the embedded working group. I'm guessing if you're here, you probably know who I am either because of Twitter or Matrix. So hi, and I'll hand it over to Ryan to introduce himself.
Hi, I'm Ryan. I'm a PhD student in Auckland in New Zealand, which is kind of distant. I've been working on this embedded Rust stuff for 2 or 3 years now, biting off things way bigger than I really can chew. And I've been working in embedded for sort of 6 or 7 years, writing a lot of object-oriented C, which is maybe familiar to a lot of people. I just chucked a Dropbox paper in the chat. When James asked about this, I put together a sort of list of things I've been working on and things I thought were interesting, and also things that I had wondered who I could hassle about, just like how to go about a bunch of improvements to the bits and pieces I've been working on. So one of the things I've been working on recently is a bunch of abstraction for embedded radio devices. My work and my research is sort of around the IoT, so I spent a lot of time playing with embedded devices and radios. And I was actually going to share a screen, I think, to show you some of that just as a quick background. You've muted yourself.
I said I think you should be able to share. If it gives me a prompt, I will hit accept.
Yeah, I just have to work out which browser.
No worries. I know. Oh, there you go. Oh, it's a cool layout for me.
Yeah, I just asked it to do just my screen, so it's pretty cool for me too. It's got a little sort of bar across the top and a green box around what we're actually looking at. So I've been working on this radio driver and this radio abstraction so that we can kind of drop different radio devices into like network stacks in the future where we have useful network stacks.
So real quick, so is the scope of this, is this packet-based radios? Is this any specific protocol or just packet radios in general?
Digital packet radios. So from all the, like I've worked with a bunch of them and kind of extracted the commonality, which is most of them you can configure, you set them to a channel, and you tell them to send some data. And there's a few little bits and pieces around there on like around ACKs and timeouts and things that I haven't really gone into yet. But packet-based radio that likes to send bytes over the air is kind of what we're targeting. So I took that apart and composed a bunch of traits from this. The two most interesting ones, I guess, are receive and transmit. And they're kind of loosely async, but not actually Rust async, right? So like anything else in embedded, you're probably going to end up polling on the status of something. So we have our like check receive here. So there's kind of a state machine that's implicit to this, right? You have to, there's a contract in the API that says, this is what you have to do. And the same with
because you've got some other actor going on, like the radio itself. Like you're going to give it something to do, and then it's going to take a lot longer to do that than it is the CPU. CPU is going to be waiting for a while for it to actually delegate, and then wait for that to complete.
That's exactly it. And like often you'll also have interrupts or like other out of band information feeding back in to let you know whether you need to recheck that or anything else. So this is kind of the first like cut of an API that works based on a bunch of the ones I've worked on in like Kentucky and Riot OS and things like that. And it's functional, but it doesn't, the contract is external, right? If you have interrupts, you then have to wire them together externally, where really what you want is to be able to drop interrupts into the device. And nominally what you want is to be able to execute all of this stuff on an async worker, or using the async stuff.
Yeah, that's a desire we've had for a couple drivers. Like the ability, like I know I have written at least one or two serial and spy drivers where I'm like, it's just gonna own the interrupt. Like you just need to not use the interrupt because it's gonna do that. Like the whole idea of like, I want a big FIFO queue with like a BBQ or something like that, where I could just give you 1,000 bytes, and even though your DMA window is only 32 bytes at a time, I want you to just keep reloading until you're done, and then stop rescheduling yourself when you're done.
Yeah, and you want to be able to package that in a useful way, right? Which is
yeah,
for other people to be able to pick it up and just like go ahead and use it. So I've been running this actually under async standard, and I was like, well, this is dumb. I should be able to make this non-blocking. And it turns out it's not extremely difficult to generically implement non-blocking like async stuff over the synchronous stuff. But the real problem here is how you pull the interrupts in and how you take care of the idea of state.
Yeah, I know Ferris is doing some work right now on, I know some other people have as well, but I know we have Jonas in the chat. Jonas, if you want to step up and talk about embedded async at some point. I'll probably let Ryan finish what he's going for, but I know you've been working on embedded async, but if it becomes relevant and you want to step up, just feel free to shout out in the chat or something like that.
Yeah, that'd be awesome. I can't see the chat anymore. I don't know where that's gone on this.
If you get out of full screen, it still is like a full screen window, but it has the chat over on the sidebar if you click chat. But you have to click the like exit full screen button, because in full screen it won't show you chat.
I got it. I'm not full screen because I'm sharing my screen at the moment, but it's in the top bar as well, and you just get an extra window for it.
Gotcha.
So the first big problem with this is that we don't really have async traits, right? Which you can mitigate via, I think it's Dutolne. Completely forgotten their name.
It's David Tolnay, I think.
David Tolnay, yeah. They have this amazing macro that goes and does perverse things to make async function work in traits. The unfortunate downside of this is it's like full of boxing, and it doesn't propagate generics quite as you'd expect. So in a bunch of situations, you can implement, you can provide an implementation over a generic type, and the async trait variants won't actually pick that up, which is kind of a bit of a gotcha if you're using this. So put together all these API wrappers that are basically generic over the blocking interface. So we give them a set of options, we set them up, we start an operation, and then we create a future and we await on that. Of course, immediately that's broken because we don't have generators, or is it named generators, the name of the PR at the moment? The ability to inject generators rather than just using the standard one.
Have you seen the other hack around that of using async await to simulate generators?
Oh my gosh, what?
There's another PR that I think it's another Dutolne hack, but someone else like that, where they've basically made a proc macro that looks like generators, and it's using async await under the hood to pull it. So you can have generators essentially, like, because under the hood, async await is driven by generators, but generators haven't been stabilized because of a couple things that actually Jonas has been working on. Of there was a couple things that they didn't like how it was implemented currently, and there were some limitations. So they haven't stabilized that yet. But someone turned it inside out and basically re-implemented generators on top of async, which is implemented in generators, which is absurd.
Wow.
But yeah.
I love it. That's amazing, actually. Classically Rust, I guess. So
Classically
yeah,
Detolne or something like that.
yeah. So the way I went and did this, right, we've got transmit feature objects that are also generic, and they poll on the transmit functions, and et cetera, et cetera. It's all like reasonably straightforward. One of the really interesting problems I had is how you actually propagate a waker through here. So in a situation where you have an interrupt that is actually operating asynchronously, so you want to dot await on it, how do you feed that through into a driver so that it actually causes the waking to happen? And I have no answer to that. This is an extremely open question.
Yeah, this is where I'd probably, like, I don't know if I don't think Jorge is in the room, but I don't know if Jonas knows more than I do about this. So I actually haven't followed their work super closely, other than from like a very high level. But I know they've been doing some work of how you can get an interrupt to essentially be the waker, where you don't do a lot of work in the actual interrupt, where you just mark basically things as ready within the interrupt itself. So essentially the interrupt fires, marks a future is ready, leaves, and then the next time the executor gets around to that, it goes, oh, okay, yeah, that has happened. Or the executor is really doing a WFE, and basically once it notices that the interrupt has happened and exited, then it goes, okay, it's time to go back and see who got marked as complete, basically. So I know, like, on the Ferris website, we have the async on embedded branch where we talk about some of this, but I will admit I haven't had a chance to dig into the implementation of this yet.
Yeah, that's really cool. I have dug into that a little bit, but I hadn't found quite enough information to make me comfortable with how that particular part of it worked. So the current trait, like, again, it doesn't really enforce the contract, and we've ended up in a situation where we have two. Hey, thanks. Where we have two implementations to some extent, where there's going to be an async version and a sync version, and that kind of upsets me. And I'm a bit worried about that from an embedded HAL perspective as well. We're going to end up in kind of a green-blue situation, if you're familiar with that.
So I've heard the terms before. Would you mind explaining the different colors, or like from a super high level?
Yeah. There's the blog post of the person who came up with it is pretty good. But the idea is basically that in a programming language, we have a set of primitives, and one of them is functions or methods, right? And generally, you pick up a function and you can call it. But when you introduce something like async, you create a situation in which the functions are like not obviously not like incompatible. And that's what the blue-green refers to. That all of a sudden you've got different types and they have different colors. And if you use functions that have different colors, which is just like purely a metaphor for the async or whatever other mechanism it is, all of a sudden you can't really interrelate them. It's extremely hard to run async code from sync and sync code from async for reasons that, as a consumer of a library or anything else, are generally not that obvious. I'd like to think that our type system is going to help with this a little bit, and complain at you if you don't execute a future or anything else, but it's still it's not an ideal outcome.
It's one of those things where, like, naively, I feel like, and we've talked about this before with the non-blocking, so this wasn't even async await, this is more like callback polling style of like the non-block crate, because futures weren't stable at that time. But the idea that, like, oh, okay, ideally you should implement everything as non-blocking first, and then always you can just implement blocking by just calling a non-blocking function over and over to completion, or polling it and getting a result, and then maybe waiting a little bit longer, or doing something else, but which still seems like the ideal idea, but I know that in practice that ends up being really problematic.
Yeah, actually, like delay propagation for features is another really interesting, difficult thing. Because like naively, I'm just still sharing my screen here. I can show you this. Naively, I went and thought, I can just do this, right? I'll just task sleep. It'll be fine. It's not fine. It's not reliable in any way. So you go from, you're like executing against a rate, and you're like, all right, I need you to wake every millisecond or every 100 nanoseconds or something else. And then as soon as you ask the scheduler to get involved, that those constraints go out the window. So I basically moved everything to a, it's not quite blocking, but we're basically polling on a timer and checking whether the time has expired in a future, because it was the only approach I could find that would actually give us like a
When you say reliable, do you mean
delays.
like the timing? Like you like lacking of jitter or lacking of like blowing over some timing constraints?
Yeah, like a little bit of jitter doesn't matter so much, but when you get the schedule involved, it just doesn't necessarily come back in a reasonable time period. So it's yeah, absolutely blowing the time constraints.
It's the pain of cooperative multitasking versus preemptive multitasking.
Yeah, and I got really excited. I was like, okay, I'll just change the thread priority. It'll be fine. But it's actually a nightmare to do it, and you're meant to do it externally, and did not have a good time with that either.
Yeah, I know one of the things Jorge has talked about is having essentially a non-time critical executor, where like the idea would be for async await that if you have a non-time critical application, that you use something like async await because it makes things very easy, because at least in my opinion, like, and I think this is the whole point you're making with the radio, is embedded systems are all event driven. Like the whole point of embedded systems is they're waiting for forever in their relative time until someone presses a button or a packet comes in or some temperature exceeds some level or something like that. And almost all of what you do in an embedded system is wait for X to happen and then do Y, which is like totally what async await programming promises. Um,
Yeah,
and yeah, so like it seems like it should be this super fundamental um match of things, but it's always very difficult because embedded systems are, the only thing similar about two embedded systems is that they're not like any other embedded system, in that like everyone wants to do a special, like, oh, I care about timing, I care about RAM, I care about code size, I care about code speed, like all of these things. So writing abstractions that work for all of these is really terribly painful. And the more we work on embedded
yeah,
HAL and stuff like that, I feel like the more we realize that embedded HAL just has to be a, works for the general case and is like a good starting place for everyone. But if you really need something ridiculous, it's not probably going to come from embedded HAL. You're probably going to fork the library or something like that and go, okay, but I need buffering of exactly 17 items at a time because that's what I need for my timing or something like that.
yeah. It's there's always going to be like oddly specific edge cases. That actually reminds me a lot of some sort of API design things I've been running into recently, which is like, you know, in the software world, people like to have like public methods and private methods and say, actually, this is on the internal. But invariably in the embedded world, you pick up a driver and you're like, I need that one embedded internal method. And like, are there better ways for us to, better abstractions we can use that let people have both the high level and the sort of low level access to peripherals and all that sort of stuff? One of the approaches I've been taking recently is to split stuff by trait. So you have like a low level trait that provides you with your like register level API that you can get out if you need to, and then you have your sort of higher level traits that implement whatever the functionality of the actual device you want to interact with is, in the hope that that'll be slightly less frustrating for someone who's trying to do something weird than like the current sort of state.
Yeah. I know Hano, when he was building the DWM 1001 crate, he ended up going into this in that the DWM is an external packet radio. It's SPI based. It's also register based, like many radios, where essentially the way that you interface with it is almost in the same way that you have memory mapped I/O, where you have a register address and data there. This is mostly for everyone, not for you. I'm sure you're familiar with this, but the like over SPI, you give it like a register ID number, like 27, where 27 will set your transmission power level or something like that. So I ended up bringing up a set of traits for low level power or low level register level interfaces. where it's just abstract over each of the different interfaces, so that you could plug any SPI port into it, but still have the same low-level access to actual individual registers, and then built high-level criteria or high-level functionality on top of that for exactly the reason that you're describing. And that's something that we've used or the DWM 1001 is something that we've used pretty extensively. But yeah, having that separation is super useful. But I think he just had one like unsafe escape hatch in the high-level method that was like get low-level interface, and it would hand you like a reference to a trade object or something like that, where it would hand you, like, I think it was one unsafe method that would hand you the low-level interface and be like, do whatever you want, but it better be consistent. Like, because you may end up like, if you turn the radio off while you were doing that and you didn't do it from the high-level interface, you might have some timer or something that was still running. Yeah. So it was basically just like if you open the escape hatch, it's on you. And it probably shouldn't have been unsafe because it's not really a memory unsafety thing. This is one of those things that people go back and forth on. Unsafe doesn't mean bad or dangerous. It means specifically memory safety. But sometimes, like, there is no other pervasive keyword in the language that means like, hey, be careful. And
heads up.
Yeah. But yeah, that was his go-to. I don't know how you could do that without either the unsafe keyword or runtime overhead of like consistency checking, like setting a dirty bit, like, hey, you've done something weird, probably maybe don't cache the state of everything, recheck whether you have that or not. Like, I can't think of a good zero cost way of doing that.
Yeah, I mean, the approach that I've taken at this point is just that the radios are the source of truth for state. So the device, the driver, even the high level one, it's not like totally stateless. Once you start to transmit, obviously, if you mess with that, you're going to have a bad time. But predominantly, you're actually just reading data out of the radio because it simplifies that abstraction. That's obviously not always going to work, but it helps in that regard. And I found myself doing exactly the same thing, especially around abstracting over different comms protocols, devices that talk SPI and I2C or SPI and UART. It's quite good to have a low-level base that gives you your register-level stuff over whatever transport, and then you can build your higher-level stuff on that.
Are you aware of any like good crates? Like, one of the things that I see, and this goes to everyone in the audience because I see some embedded people in the audience as well. One of the things that I keep going back to, and almost every external peripheral uses this, is this like concept of a register-based interface where you have like ID number and then some arbitrary number of bits or bytes that need to go into that register or need to be read from that register or need to be read and then, or written and then read or something like that. I haven't seen any good generic crates that are like that help you abstract over that, where you can just be like one big table that's an ID and a function or like a data type or a Serday serializer or something like that. Like, I've seen a lot of crate specific ones where people have built like a macro like this is what the DWM 1001 has, is like a macro that has one big macro table of like all the types and the number of bits and the number of bytes, and like it's a really big, ugly, gnarly macro. But I haven't seen any like crate that's a good convenient abstraction. That's one of those things that I could see everyone embedded using for both SPI and I2C in particular.
So you're kind of imagining like we have SVD files that give us our register configs and all of the bit fields and stuff, like an equivalent for that would map into peripheral space, or
either like a proc macro or a builder or something like that. Like SVD, I've had actually people specifically ask for, how do I get SVD for my external temperature sensor? And we're like, well, that's not really a thing because SVDs describe processors and their registers and things like that. But I've absolutely had specific requests from people asking for like, I want SVD to rust for a radio or for a temperature sensor or something like that. But even just like a proc macro of that kind of stuff. Disasm saying just override vcell. Well, I mean, like sort of like even like some kind of crate where you could like proc macro or something and like give it a generic SPI or give it a generic I2C, like something that was generic over the embedded HAL traits that does like read then write. So most of these interfaces have like a write then read or a write with like two segments or something like that. Are you about to show me exactly what you've built for this in your crate?
So I noticed this writing a bunch of SPI drivers, and I wrote this, I guess. So I've got a prefix read and a prefix write command, and they're just generic over our new and not yet landed transactional SPI traits, because this is so extremely common. As well as a set of other traits that were like, actually everybody has busy and reset and ready and things like, so this is just like a really simple
State
common
machine
abstraction.
as a service.
Well, it's not even state machine really, like it's one operation then another in a fully blocking context. There's no like, I don't know, it's not complex as far as things go. But this is only half the problem, right? Like half of it is that you need this ability to read and write and do the things you want to do. And to some extent that's mitigated by the transactional traits when we actually land them. So, you know, anyone who's in the hell and feels like reviewing that PR. The other half is generating the stuff like this, I think.
Yeah.
Is that what you're referring to? So like with a given device, you've got a bunch of registers and the values for those registers, and you need to be able to configure them and probably serialize and deserialize them.
Yeah.
One of the problems that I've had with just about everything is like when I write a driver, I really like to write a utility for it as well. So hook it up to the Linux embedded HAL implementation, or in fact, I've just this embedded SPI crate of mine. I've just added a HAL layer that abstracts over different SPI implementations. So I use quite a lot of like USB SPI devices, the CPU2130s, also Linux, and I've got to add FTDI to that, which means that you can just like runtime select the device that you're looking to, that you want to communicate with for these utilities. But
so you have like a little CLI tool, or?
Yeah, I got one. I can show you if you like.
Yeah, definitely.
I do have to work out how to share the other screen.
Yeah, I think you have to you have to stop sharing and then maybe start sharing another one. Oh, there you go.
Is that working?
Yeah, I can see one terminal and I can see the chat over on top of it. Yeah.
Oh, interesting. Chat's gone now?
Yeah.
No stress typing.
Yeah, it's the worst. I give trainings, and that's literally, you never type worse than when there's like a room full of people staring at what you're doing. I can hear your computer struggling with both video encoding and running Rust. That's my other trick for training, is I pre-compile, and for streaming, is because usually I stream directly off my laptop, and like I just pre-compile everything, and then usually like halfway through every stream, I hit cargo clean, and everyone just goes, or I just go, oh. And I'm like, okay, I'm going to take a break. I'll be back in 5 minutes when my computer is actually done building this project.
Yeah. I've got a copper heatsink on this one, so that it's got like way less thermal inertia than usual. So you really get a lot of like, you can hear every time Rust is invoked.
Yeah.
So this is one example utility for this SX128 device, which is a 2.4G packet radio that can do all sorts of stuff. One of the interesting things is it's got this FLRC encoding, which is like quite impressive channel capacity approaching code. It gives you like frighteningly good performance out of 2.4 gig. Still nothing compared to like GFSK at 433 megahertz or something else, but like kilometers from 2.4 gigahertz at like 10 dBm, 15 dBm, which is reasonably unbelievable, and at like hundreds of kilobit
Excellent
baud rates. So this is one of the utils.
Is the 1280, is that a LoRa radio? Or I guess it's not, it's 2.4 gigahertz, so I guess it's not one of the LoRa. I've only used this, that's the Semtech, the SX ones are the Semtech parts, right?
Yeah, so this is a Semtech. So it is technically a LoRa part.
Okay.
The 12.7 and the 12.6 series are their sub-gig LoRa.
Okay.
The 12.8 is the 2.4 gig, and it does have LoRa modulation. So you get to choose between LoRa and FLRC depending on the bandwidth that you want.
Okay.
LoRa supports the like lower speed, lower data rate channels, and FLRC supports up to like 3 megabit or something completely absurd.
Nice.
Yeah,
I've seen the like the 802, or it's not 802.15.4. It's what's the what's the 6 low pan radios? What like
From
Thread
who?
and all them use? What phi or what I'm showing my lack
The
of knowledge here.
NRFL is the extremely common NRFL
Oh,
something is the
I'm just thinking of
Nordic
like what
chip that people drive.
I'm just thinking of it's the 802.15.4s is what I'm thinking of. Like all the
Okay.
802.15.4 style radios, like either whether it's
Yeah.
sub or multiple gigahertz or sub gigahertz or all of that.
There's an interesting delineation there, which is like just about every packet radio that's available will support some or make some attempt at supporting like 802.15.4G. So there's like quite a difference between devices from like Atmel. They have a chip called the ATE86RF212, which I've
Mm-hmm.
also got a driver for. And that one has quite a lot of the like state logic for 802.15.4 built in. Actually, quite a lot of like intelligence. Whereas like the Semtech LoRa devices or the like Silicon Labs sub-gigahertz radios and stuff, they're all 804 802.15.4G compatible, which means they can put packets over the air that are compatible with 802.15.4 in the extended frequency range. But usually the only functionality that they have around that is maybe like addressing an auto acknowledgement. And you're
Mm,
actually expected to handle like the vast majority of the stuff in the stack.
gotcha. It's like the managed TCP/IP stack chips versus the like I'm just an Ethernet PHY kind of chips.
Yeah, very much. So I've completely forgotten the one, but I know what you're talking about that people use because it actually just manages all of the
Yeah,
15.4
it's like the
magic.
WizNet chips. Oh
Yeah,
yeah, but like for Ethernet,
WizNet
it's like the
equivalent.
WizNet chips. Yeah, but yeah,
Yeah. Um, so this util is running over this like abstract hell. It's pretty simple to implement. We load up we're using struct up because it's easy, and the hell comes with a struct up object that you just flatten into your like whatever's relevant here, and then you just ask the hell to load up a viable configuration.
so we had someone in chat saying that the audio is super
Sounds
choppy.
super sharp.
Is
Yeah.
so you're sounding very clear to me. I don't know if anyone else is anyone else in chat having choppy audio problems, or is this just like on the receiving end?
Yeah, you're sounding extremely clear to me.
Okay, yeah, we have a couple other people saying it's clear on their side, so I think it may just be that one person's internet connection. I'm not sure the best way. I mean, if you have the opportunity to use wired internet, then that's probably better.
Yeah,
I'm
I'm
not
actually on
sure.
Wi-Fi,
Yeah, well, I'm on Wi-Fi as well, but if they're
but
yeah,
yeah,
I'm not sure. Maybe try leaving and coming back. You should be able to be let back in the room, so maybe close Zoom and come back. I'm not sure if there's a way to change, like YouTube style, change your settings so that it's lower but more reliable. Um, but yeah.
yeah, there's nothing extremely obvious in the settings.
Ah, and they're actually on fiber, wired fiber.
Oh.
So your internet connection is too fast for us. So yeah, that's so you have it
And
just running through the embedded HAL traits. That's basically generic over different kind of SPI devices that you can have. I'm guessing. So if you ran it on a Raspberry Pi, you could use the native like device tree or sys interface SPI, and on
yeah,
here with a USB device, you can use a USB device.
yeah, exactly. And it's a little bit difficult to propagate that via struct opt because you can only have one subcommand, right? So you can't necessarily have like a tree of configuration objects. You have to flatten that manually. But like here, for example, you pick your CP230 device, and that's just an index, or
I'm
you
pretty sure you can
and
have
that
nested menus in structop. Like you
only
can have an
once.
enum inside of an enum inside of an enum. Like I've done pretty deep trees with
Oh,
structops before.
yeah, but you can't have enums side by side.
Oh,
right?
okay.
So here I have both the SPI configuration, which is one like nested enum, and then the
Mm-hmm.
operating mode of the radio and stuff, which is another nested enum. So the
Gotcha.
only approach I've come up with that might work for this is to actually manually like partition the arguments, have a double dash between the like config and the operating.
Interesting.
Um, but so at the moment it's flat. So you just, if you give it an index here, or you give it your like /dev/SPI, whatever, and if I run that now, I've just loaded one in, it just picks out what to do. And then you can talk to it.
Nice.
So I really have no confidence in drivers that I've written until you actually test them, you know. And having a little utility that runs on Linux or like a USB device or FT.I, like whoever make it, the USB device, really gives me a lot more like confidence in working with these things. And it means you can develop natively rather than on embedded, which is just so much better for debugging.
Yeah, for the last device that I worked on, it was actually for a little button grid. So I've been sitting here playing with the membrane for it because I have very nervous
Oh
hands.
yeah.
But I was doing a bunch of like UX development, and I was doing that where I was like flashing it over and over, and it was even a device that didn't have a debugger on it. So I was having to like it has the DFU mode, and I had actually written a panic handler where you could force it to panic, and on a panic it would notice that it had panicked, and then it would jump directly into the DFU bootloader by just doing like a go-to. So like I could force it to do it with like in my make command, I would basically just command it to panic, and it would reboot into DFU mode. And that was even a pretty quick cycle, but like it was much slower. And I ended up writing. I know Disasm's still, or no, Disasm's still in the chat. He's written a way better version of this, but I wrote just like a little thing that listened on USB, and I wrote a little Serde interface there where I could send commands for I2C because the LEDs and buttons were all controlled over an external I2C device. And so this would
Yeah.
just listen over USB, and you could tell it to do like I2C read, I2C write, and you would just like serialize the commands over USB. So I just wrote my own USB to I2C adapter, but it was using all embedded HAL interfaces so that I could run the driver and the application that are just using embedded HAL interfaces on my PC and have that all proxied over there. And I know, like, it seems like everyone in the embedded working group has written one of those. Like, everyone, like, there's USB thing that you've written.
Literally
Daniel
everyone has
Eggers
this
in there, and he's
problem.
written embedded bridge. I know Disasm literally is giving an oxidized talk about, like, an even crazier version of this. Yeah, everyone, and, like, people have written in C. Like, everyone has written this, but, like, it's one of those, like, yeah, just reflashing embedded over and over is a pain in the butt when all you're doing is doing non-time latency things. Like,
Yeah, it really is. Actually, on that front, I would love if I never had to do this again. Like this project of mine, I don't know if you noticed, I did this 5 years ago,
nice.
and it was extremely useful when I was developing drivers in C, but like haven't ported it up to anything new. I think this would be a really good candidate for like an embedded project, and if we need to spin some hardware, like it'd absolutely be worth doing.
Yeah, I've even wanted it for testing and things like that because I like for some
Yeah,
safety critical stuff I've actually built 3 or 4 instances of hardware in the loop testing racks of something that like you have your production hardware and you wire it up to a bunch of external hardware and you run continuous integration against it. So like every time someone checks in a code in a branch, it will run like maybe the 5-minute smoke test, and then before merge to master you run like the 1 hour test suite, and then every night maybe you run the like 4 hour test suite, and then once a week you run like the 48-hour cycle which checks battery usage and resource consumption and like burn-in test type stuff. Like I've built this for a couple safety critical products, and like some of them have been using like really expensive off-the-shelf equipment. Some of
yeah,
them, and for the not so safety critical companies, have been using like Raspberry Pis and Arduinos. But yeah, just having something, and someone's actually started selling one of those where it's just like a box that does this, and they have a driver side API. But like 3 or 4 times I've written a Python testing harness that talks to a C or C++, usually low level interface on the PC, which talks to a C interface on an embedded system, which like proxies all these commands and does scheduling and things like that. And I know Hano
Yeah.
is actually working on a project for a customer right now where he's building some fundamental parts of this. But like all of these kind of RPCing and scheduling items all are something that, yeah, I've done like 5 times over my career. And I'm like, I want to do it one more time, open source, and then be done
And
with
then
it.
never
And like,
again.
because the problem is all these things that I've built have been proprietary for a company I've worked for. So I didn't get to keep them when I left, which is painful. Well, some of them
Yeah.
painful, some of them I'm glad to be gone. But like, yeah.
The other like good side of it is like developing on a Raspberry Pi kind of isn't that great for Rust, especially because our compiler eats CPUs, and then like quite a lot of us use macOS for various reasons. It's pretty nice to be able to just jack something in,
Yep.
be able to develop embedded devices on like literally whatever platform. So actually, one of the like slightly wild things I've got working is cross-platform builds across everything with this embedded HAL driver. So we don't. There's a feature that hasn't quite landed in stable that lets you change your feature flags based on target architecture. So at the moment, that's a bit manual.
Oh yeah. I have seen that.
But the wait, has that share come back?
Yeah, you're on the GitHub page, the Rust Radio, like where your mouse is right now.
Cool. So I got this working.
Nice.
Extremely recently, which is
that something? Are you using Trust for that, or are you using something?
no, it's custom because I need libUSB to get linked in somewhere. And it turns out that the different linker backends handle that in different ways, and that the libUSB sys crate, which sort of shells out to package config and doesn't really have any useful overrides, is like a real nightmare to get cross-building. There's a whole lot of really silly hoops to jump through that like hopefully we can remove as we go along.
Yeah.
But having that ability to just like pick up a util or pick up a driver, compile it on whatever platform you're using, and like develop stuff is pretty neat, I guess. The other
really
thing
fun.
that I would.
Sorry, go ahead. I want to hear what you're gonna finish and see if it's exactly the same thing that I was gonna say.
I think it will be going back. But the other thing that I would really like is to not spend tens to hundreds of thousands of dollars on PXI stuff anymore.
I was gonna ask you if you've hooked up a REST front end or like an RPC front end to your utility, so you could do something like run it on a Raspberry Pi with a network connection and have all of your hardware sitting in racks somewhere else.
Oh.
I knew you had something like that.
Oh, yeah. So one of the things I've got that I can't show you because it's downstairs in my office is I've got a little pile of Raspberry Pis with like expansion, like the little adapters with like radios and different peripherals jacked into them, and they're all hooked up to a build kite, I think, CI manager. So the radio drivers at least, they have like an integration test that actually goes and slings packets side to side, which is kind of fun. But like having those devices, I was like, surely I should be able to develop on those from anywhere. And then, well, this is what happened. And it's not extremely good. I'm not sure I'd even describe it as good, but it is possible to use. So basically it runs a daemon that gives you a bunch of commands that let you configure peripherals and use them with embedded HAL APIs from the other side. And because I like utilities, it's also got a command line client, so you can thrash that from wherever. This got, I ran it a little bit, but the latency issues, the timing issues were like too significant for me to feel like it was really worth pursuing. You know, it's kind of too low level of a protocol to do over, or to reliably use over IP.
So I'll share you something that I was thinking about building.
Yeah.
So this is all imaginary code, but it's I mentioned, or is this it's drawing the line down the middle. Is this actually like, can you see a GitHub
I can see the
script?
line, but we can see the whole page. I don't know what's.
Let's share the desktop instead. So you mentioned like having problems with it being live. So I have this, and I know how I would build this. So this is Python, but think of this as the front end, so the test language. And there's definitely some like event-driven things going on here. I'm not actually going to go too deep into it because I might still do something with this, but you might be tickled by this. So the idea is to have a rack, which is this device that is your backpack. So you have your unit under test, and then you have the rack that's sitting next to it that's simulating all of the commands that go to it. So the idea is to kind of reset the rack. So this is like a state machine test for, let's say we had a smart lock where we had like a knock pin, and then somewhere where you have to send the password, and then it's going to have some line coming out of it where it's driving the motor to unlock it if it's happy with that. And right now the password scheme is you drive the line low like you're pressing a button, and then you're supposed to say the word hello 3 times in a row. Like pretend that that's your authentication scheme or something like that. So the idea is to have this totally configurable rack, which is like just an off-the-shelf microcontroller based board or an FPGA board or something like this. You set it up. These are going to look like some familiar naming schemes. The idea is to like configure certain pins into certain modes, like a floating input or a push-pull output, or as a UART TX. And then the idea is that almost all of this, because you described the problem of it's hard to do this in real time. So the way that I get around this is you make everything event-driven. But all of these events are described a priori, and you upload the event sequences to the actual test device and tell it what it's going to do when something happens. So you could have some kind of hello action that says like, when the GPIO rises, specifically the knock pin GPIO, you attach the action that is the hello response. And the hello response is just the hello action, which is a class I defined down here, specifically with the UART pin, where the hello action it just sends the word hello over the UART. So like you press the button and it will fire back hello. And then you have the lock response, which we don't need to actually respond to that. We just need to log when it happened. So by default, you get like logging and the fact that it's a one-shot, or by default, logging is off and one-shots are off. So this says like, this is an action that only do the callback once. So like it's a one-shot callback, and we should log the response. So just say when it happened, because we don't need to do anything when it happens, but our testing framework needs to know when it happened. So we say the lock response is an action. Pin 2 event is when the lock pin is falling, and we attach an action to that. And then so what we're going to do is we're going to press the go button, or we're going to set it high so that it's not active right now. So we set it high so it's inactive. We assume it's active low. And then we power on our target. So we've set up the simulation. We've given all of the callbacks and actions to the test device. And then we go. And then with a timeout, we pulse the go pin, like imagine someone walked up to a smart lock and pressed go, and then you're supposed to like authenticate with Bluetooth or something now. So we basically then just wait until the hello response has been triggered 3 times. And we just wait until that happens. And because we're within a timeout, if it takes more than 5 seconds, we're going to bail anyway. We wait a little bit longer to make sure that it doesn't like glitch and hit it 4 times instead of 3 times. And then we just check that it was triggered 3 times, and that basically our lock unlocked once. So like it knocked 3 times, and then the lock unlocked once. We make sure that we get the time that the last knock was triggered, and when the lock was triggered. So like when the last knock happened to when the lock unlocked, because we have some system requirement that says it has to be within 10 milliseconds or something like that. So then we can check the delta times there. And that's literally the whole test. And the idea is that we have an embedded system sitting over the network, and we send all of this configuration and these callback actions to this unit, this testing unit over the network. And you can set up different scenarios with different callbacks and different actions and different behaviors. And you feed all of this using this high-level language like Python. But this all serializes down into something that can be hard real-time. Like you can get nanosecond level turnaround times. And this looks very async awaiting, and that is part of how I plan to implement this. So I'll admit I haven't implemented most of this. But yeah, I've had this idea for a while called Rack Automat, and this is supposed to be my last implementation of a remote control embedded device, or a last implementation of a hardware test rack kind of thing. But the way I have designed, I've shown this to a couple people, but it's super over engineered in my brain right now, because it's like covering like literally every use case I've ever had in my career for hardware testing. But I got to figure out how I can come to a very specific use case of this.
Yeah, I love the idea of it. It's very in line with like TensorFlow or Vulkan, if you've like dug into either of them, where you like
I'm familiar, but
TensorFlow
I've
is a
never dug into
really
it.
cool example. You sort of write your composition in Python, and then you hit execute, and it actually just wires up a bunch of underlying C. So you're not paying the FFI like penalties for each of the different steps, or at least this was the case years ago when I looked at it. Anyway, so I really like the idea of that. That's really, really like neat and would be extremely useful. The problem I have is that while it can do hard real time in some regards, it's really hard to do something like wire that into a peripheral. And these are different types of testing, so it's not necessarily like useful in both cases, right? So I've been kind of thinking about the same thing, and I've loosely gone down a different path, which is extremely cursed. Which is this, where I'm like, okay, so I want to be able to have at least slightly real-time code executed on another platform. I don't want to recompile. I don't want it to drop off my network.
So
Also, I'm sick of writing C.
I'm sad Jonas isn't here anymore, because literally when I was designing this, at some point I took a step back and I looked at this really cool event-driven architecture I built, and I stepped back and I go, I'm literally writing a programming language interpreter. Like, I am building a programming language right now over RPC. So like, to be honest, I'll admit, this is the other, like, I actually evaluated both of these of having either, I looked at Lua and Wasm as my scripting language, where I went, at some point, at what point does it make sense to just go, yes, I am building, actually, it was Lua, Wasm, and CircuitPython were the three that I looked at, of like, when I'm building a test unit, at what point do I just say, just run the damn language on the end device? Because it's easier than writing, like, basically the trade-off that I looked at it here is that the Wasm, the CircuitPython, the Lua was going to be vaguely slower, and like it would require more resources, but for test devices, I actually don't care about the cost.
Yeah, they can
like,
be extremely potent.
A $50 dev board is not different than a $10 dev board when it comes down to like the amount of time that people have to spend writing the tests.
Also, $50 on a test system, you're already saving like 2 orders of magnitude.
Yeah.
Anything that costs that little.
Yeah, exactly. Like, even if like the plan would be to get one of those like IMXRTs, like I know Arturo 182 is building a IMXRT, I think one of the 1061 on a Feather. The plan would be to use one of those, or what I have in mind for the first version of that Rack Automat is one of like the STM32H7s with a bunch of level shifters and stuff like that, so that it's like, it's a 400 or 500 megahertz device with a ton of RAM, a ton of flash, like, but yeah, that's the trade-off, is like, do I need that last like order of magnitude of performance to be that hard real time at the cost of you have to think in two different modes, because you're writing software that gets turned into an RPC call, that gets turned into a runtime execution environment on, like, I'm basically like compiling my own callbacks and things like that, versus just writing Wasm, Lua, or CircuitPython and running it on the end device itself.
So interestingly, I was chatting to one of the CircuitPython peeps, and they're actually looking at, I don't know whether this is like official CircuitPython thing or something this person was interested in, but we've been interacting on the Intel Wasm interpreter, which they've been looking at targeting as a CircuitPython output, just as a possibility. So they'd quite like to be able to compile CircuitPython into Wasm, then then ahead of time then load that onto the ESP32s, which kind of raised for me, and like I really should have known this, have written things doing this before, but like we can just do outfloating, right? I haven't
Use
tried.
load to RAM.
Load wherever. man, you put it in Flash, it doesn't matter.
Oh, that's true.
But some of these devices have enough RAM that you can reasonably put an application in. So like,
Jorge has been working on a thing that's not super public, and I think he's talked. I think I'm only talking about the public part, so I'm going to talk very carefully about it. But he's been working on this thing where he wants to have this like tight development loop experience where you have like basically a really simple bootloader running on the device. And I don't want to spoil too much. You have a very simple bootloader running on the device, and when you hit cargo run, it just loads that into RAM and then begins execution out of RAM. So that when you hit cargo run, the loop cycle is almost nothing because you just dump it all into RAM and it takes no time, and then you just begin executing out of RAM. And then like it has some extra stuff in there like panic handlers and fancy debugging things. So if things go wrong, it still fails gracefully. But he's been building this really cool tooling that I don't think he's tweeted about it, so I don't feel bad mentioning it. And I think I'm only talking about the things that he's tweeted about. If not, then maybe like a little bit more than he's tweeted about. But it's this really, really, really cool, like somewhere in between the like I'm doing ridiculous things remotely and just like I'm building application and it is that fast to iterate on. So like you get this super tight iteration loop.
that's really cool. That's kind of what I was targeting with this ESP32 WASM thing. So there's an HTTP API, and you actually run the thing, and it spins up all of the common stuff that every IoT device has. It connects to your Wi-Fi and manages that properly. It does MQTT if you want that, all this stuff. And the intent is that there'll be some like event passing sort of between that and your WASM component. And then so you cargo build, there's a couple of WASM commands you've got to run to like strip the debug symbols and stuff. And then you just post it to the device and it runs it. I haven't quite got getting the logs coming back, which I think would be extremely cool. So you actually like send a request and then have the terminal on your local device. Yeah. But that like completely simplifying the process of like deploying testing code, and also meaning that I could have like a common image for all of the ESP32 trash that I have around the house and just like load little applications.
Yeah. I was looking around for it. Arturo made this really cool little board called the Serpente, which is it's a Circuit Python board, but it's super like I was blown away. Like I think it's just because I'm not used to not having to write drivers for everything that I'm doing, but like the fact that I just sat down, I had a REPL and I could import a driver and then just hit like neopixel.turn on and it just turned on. I was like, wow, that was great. Like I'm so used to having to write like raw SPI drivers and stuff like that. And I think it's just because like the circles that I hang out in, I tend to do that more rather than like, I'm sure like if I just sat down with an Arduino again, it would be like that magic again. But the fact that I could just plug it in, it gave me a REPL and I could just go for it. And then like I needed to load a new driver. It was just like drag into the USB drive and let go. And then it was like, cool, now I have that driver. And I was like, wow, that's like, I would not want to use that for like production, but for prototyping, that's amazing.
That's pretty cool, eh?
And it's just quick. A little like it's in one of the Atmega like SAMD 51 or something like that. It's not a super powerful chip, but he just put like an 8 meg SPI flash in there and it's fast enough to do Python-y things.
I'm really excited for the next cut of the ESP32s actually, because rumor has it, the like initial prototypes appear to actually have their own USB device. So like one of the limitations that we have at the moment is that we've got these like USB serial chips, and the interface that you have is serial plus like RTS, DTS for doing the reboot bootloader magic. But when we can actually run like proper USB device or proper USB interfaces, we should be able to achieve stuff like actually useful Circuit Python with the throwing Python files in and out of a directory and all that, which is hugely more useful, I think.
Yeah.
I feel like there's a lot of people working on different sort of magical bits, and having a podcast kind of thing where you talk to them about it would be a pretty neat.
Yeah, I should just keep talking to people about the magic stuff they've built, because I feel like there's a lot of stuff that people have like half built for their own interest, and like we all want mostly the same thing. And I think like last year was really rough for the embedded working group. I think like it was recovery from the year before, so last year was kind of like a holding pattern year, it felt like. But it feels like we've come out of the gate this year and picked back up. Like it felt like we had the year and it was like, rest time. And now it's kind of like ramping back up this year where I feel like there's been a lot more involvement and there's been a lot of new faces that have been very active and embedded that I've been
Yeah,
super
that's
like
been very cool.
half the names in this chat I don't like. I know some of them or I've seen them once before, but like people that I haven't had conversations with, and I'm super excited about that. And so like I think we need to have that conversation next week about like retooling the teams, because I think there's some people who have moved on to other stuff or looking at other things right now, and like that's okay. Like open source is super demanding and draining. So like
Yeah.
getting people rotated in where they can contribute and can be that, I'm actually super excited for. So that is something like I am actually really excited for to see how it's gone. And even just from like wearing my Ferris hat, like the interest in embedded Rust has been picking up in companies a lot too. And I think it's
Yeah.
like interestingly more than in other areas of Rust comparatively in my experience. And I think part of that is that like the gap between what is status quo, like if you have someone who's writing backend applications, like they're probably fairly well served by Python, Node.js, Go. Like you can say whatever you want about like, okay, Rust is better at some things versus the other, but like the delta between a reasonable Go environment and a reasonable Rust environment is not actually like maybe one order of magnitude or less, like in terms of convenience, in terms of comfortability, in terms of performance and things like that. Depends on where you're comparing what to what.
Yeah, and it's
Um,
definitely not always in Rust's favor from working on these things.
for the
Like it
convenience, especially for
definitely
like
goes both
maturities of
ways.
libraries. Yeah. And
Yeah,
it's very back and forth. But
it's a
like with
constantly
embedded,
moving target.
yeah, with embedded is um so many, well, one, like I have a lot of rants to have about the average state of embedded development teams, in that there are some that are very good. Like I've worked on teams and I've helped and I've consulted with teams that blow my mind, like the kind of tooling that they have, their process, like what they have working reliably and things like that. I'm like, yes, that is exactly what you need. And then I walk into other teams that are living in the Stone Age. Like they still
Mm,
pass around zip files, they've never heard of a unit test. When I say pass around zip files, like no source control, they just pass around zip files like this is firmware release final version 2. um like no documentation, no tooling, no whatever. Like once 5 years ago they figured out how to set up like an IAR installation, and they've just been using that, and they know what none of the options do. Like they don't know the difference between a linker and a compiler and stuff like that. Like, and it's not an insult to them, it's just that I've found that either you've worked on a team where people know a lot of stuff and you've had that knowledge transfer, or you haven't, or you've been part of an organization where everyone left and you came in and that knowledge was never transferred. And there is no like push for education. Like there is no coherent C embedded ecosystem. Like there is nowhere where you can be like, what is priority inversion? Like you can Google, if you knew what the term in priority inversion was, you could Google it, but there's no like singular collection of vocabulary or terminology, or there's no like I talked to some people like the Memfault people. I actually talked really extensively with before they formed Memfault and before I formed Ferris. We actually sat down and had a really long chat, and we wrote this list of like everything that they don't teach you after a university degree in embedded systems that literally make or break um, a successful project and an unsuccessful project. Like I need to pull this up real quick because like this is one of my other soapboxes.
yeah, have you
Um,
got that somewhere? Because I definitely appreciate having it to read and
yeah,
or share around if you put it into a
of
public forum.
eventually, yeah, I've shared it around before, so I don't mind and I wrote it, so I don't mind. Um, the where is it?
Um,
It's got to be like 2 years ago now.
I do totally agree with you that there's a huge gap between like the embedded world and the rest of the software world, and it kind of almost feels to me like that gap is constantly widening with the amount of effort that's being put into web tech at this point in time. Like
Yeah.
it's, I'm so glad that the Rust team have a commitment to embedded, because otherwise we would be completely left behind again.
I mean, to their
Um,
credit, the only thing that the thing they've done is just like they get out of people's way when they have. So like we broke this up into different categories of design, build, debug, test, observe, debugging tools, and system architecture. The
Yeah.
idea was to write a book about this. So this is just the titles of what we were planning
I'm
on
not
building.
sure you're sharing the right
I'm
thing.
not sharing my screen. Wait, what did I, oh, oops, wrong desktop. I was looking at a link someone else sent. Okay, is it
Yeah,
sharing?
it's a bit zoomed
Now
in.
it's a gist. Okay, yeah, I meant it for it to be like, and the idea was that this was kind of like a skill tree of like things that like this isn't sorted as the skill tree yet, but like items that would pay dividends. Like for example, like CI builds don't make sense when you don't have version control. So like we have, it's not in this document, it's somewhere else that would take me longer to find, of an actual skill tree of what this actually is. But like version control, documenting building environment, like what version of tools do you use? What version of linkers? What is your host environment? What are libraries you use?
Docker's made this really easy, fortunately.
For some people, if they know how Docker works. But most embedded devs, I would say, probably don't know how Docker works. One-touch build, the ability to just type make and have all of your like configuration in one place, so you don't have to be like, oh, you have to select this from the drop down and then do this and then do this, or like test builds, you have to reconfigure it like that. Having some kind of style guide, like having consistency in your code base, reading and enabling your compiler warnings and listening to them, those kind of things. Like even like GCC and Clang's compiler warnings have value that a lot of people don't put into them. Having some form of regular code review, whether that's on pull requests or like sit down code reviews, defining your build environment. This is actually the using a VM or Docker to not just like write down what you have, but to have a tool enforce what you have. Static analysis, this is like max stack, linters, ASAN, TSAN, or I guess those are dynamic analysis, but like sanitizers, things like that. Reproducible builds, where you can actually have reproducible builds, so you can prove that if I build it on my machine, it's the same thing that you built on your machine.
Can we do that?
What's that?
Can we do
Rust
reproducible
can.
builds?
Okay. It's not always great on it. There's some things that it can't do, but there are people who are working on reproducible builds. I bet you it's easier for embedded, particularly when you turn CodeGen units 1 off. Like for example, things that are linked are in a sorted order and things like that. So there are people who are working on that. I think there's still some like, I'd say 90% you can do that probably today. Having CI builds, like having a server that builds it and there's a difference between it works on my machine and it doesn't. What the concept of test-driven development is, or even like having testing and things like that. Doing continuous testing, like not just does it build, but also like, do my unit test pass, do my integration test pass, do I have hardware testing? Release deployment, this is things like managing rollouts and things like that, and having tagged images and like quality management of your release process. Lifetime CI metrics, like is my build increasing over time? Is my memory usage increasing over time? Or my resources increasing over time? Continuous deployment, this is like rollouts. I can't remember what the difference between 1 and 2 are, but there are difference between like staggered rollouts, named identified builds, like there's a couple things in that category. And things like runtime feature flags, when you have continuous deployment, how do you do like staggered rollouts for connected devices and stuff like that, where like everything has the firmware and you only turn it on incrementally. Things like debugging, you wouldn't believe the number of embedded teams that ship production devices that I've gone and sat with that like don't know how to use a debugger, like either IAR or GDB, or like the concept of having breakpoints, but like even eyeball debugging, like blinking an LED to show that the device is still alive, or using printf debugging, like got here, or like periodically printing reports or things like that. Yeah, remote control debugging is like GDB or things like that. Instrumented hard. Sorry, I could go down this. Sorry, this is a much. I shouldn't go one by one, but like this is like all the stuff that the teams will have some of this. Like someone learned about it, or someone read a blog post about it, or like they learned about it at an old job. But if all of the teams, regardless of whether they use C or Rust, had all of these things, that'd be huge. But like the difference is, I see the Rust embedded community understand these things, like because they're usually coming from this understanding of other languages that have all of this and that expectations are there, and they aren't telling themselves, oh, embedded is special, I can't have nice things. Like, and it's just like a mindset gap between C and Rust developers for me. But now I'm ranting.
Yeah, there's definitely some like big maturity differences, and I guess kind of because the ecosystem hasn't changed, people have sort of stagnated. We also don't have any like organizations that help. There's like very few embedded conferences, which is another sort of thing I feel a bit sad about. But the flip side is we're getting so much better at it, right? Like Cortex debug in Visual Studio Code is amazing. It's like
Yeah.
Docker's given us the ability to do a whole bunch of these things. And like hopefully Rust with the embedded HAL and all that is really like getting us from a point where you literally had to take everything and write it yourself all the time, even in C++, because the STL for inexplicable reasons depends on malloc and free in ways that you never could usefully use, to having package management that works, like testing that works, debugging and programming, all of that just out of the box.
Yeah.
Is pretty great. Or this is why I'm excited about embedded Rust.
Yeah, it's one of those things where like a lot of the things I'm excited about in embedded Rust have nothing to do with the language. It's just like the ecosystem and things like that are around that,
Yeah, the space to get it right this time, I think.
Yeah.
That book document would be an extremely cool thing to have as just like a working project. I think, like if you'd contemplated that, just to have as one of our Rust embedded books, but just general embedded.
Yeah, I've been meaning to write it as a book. I actually, like I said, this list came out of a brainstorm with me, the Memfault, and some other folks. Like I sat down with some ex-Pebble engineers, some of them have ended up at Memfault. Some of them ended up at different places. Some of them went to Oculus and things like that. But we just sat down for like a day and we're like, and they were a team that had everything. Like they honestly had, like, Pebble had better tooling than some of my safety critical companies that I've worked in terms of like
everything was unbelievable. Did you ever use their dev tools?
Not their dev tools. I had a Pebble, but not their dev tools.
So they had their like C application loading stuff, and the reason FreeRTOS has elf loading is because Pebble pushed it, right? But you could like open a browser with a like web editor in it and compile C and execute that internally in a runtime on the browser and interact with it that way, and then click a button and have it load over a socket onto your watch. I have never used like anything that compares, and I'm not sure anything ever will. That's one of the saddest things about Pebble going under for me. Like apart from the fact they were awesome devices and everything else, is that you can't point anybody at that anymore. It was that like,
they even had some even more cool stuff that I don't know how public, but like things like debugging and catching core dump style things and reporting those and recovering from those and like staggered rollouts and feature, like that list that I put up there is essentially like the best of my safety critical projects, Pebble, and then the places that they've gone to work since then, which is a variety of different places. So it's essentially a list of like the 5 or 6 of us who were in the room that day, like just smashed our heads together of all the stuff that made a difference in every project we had been a part of. And like that list is basically the topic list of, if we hired someone who knew all of these things, or if you had a team that all knew how to do these things, then it would be amazing. Or like as a consultant, that list is like a good chunk of the things that I get brought in to do. Or I don't have it sitting around, but Koopman, for the safety critical people out there, Koopman has a book called Better Embedded System Software. That's basically his blog. Like he wrote about like the things that make a difference in embedded systems design. And he wrote a blog about it and eventually turned that into a book. And that's one of those things when I sit down with especially safety critical teams, like I just tell them to buy, like every member of their team should buy a version of that book. And it's still all in C, but it just talks about like how to think about these problems and like to think about worst case execution time and to think about how you use a watchdog. And like it has one of my favorite phrases in there, which is just like your project should have just enough paper, where it's talking about like you should have documentation but only enough to meet your actual needs. And like I know we're ranting now, so now is probably when we should probably save more for another talk, because otherwise I think we'll probably talk for 3 or 4 more hours on this and I need to get to bed at some point.
Yeah, that's probably a
So
good idea. I did have one thing I
yeah,
was hoping to hassle you about, which is just briefly, if you're willing to stay up a little later,
yeah. It's
which is
only 11 o'clock now, so it's pretty early for me. But
well, look, I'll be getting up at 5 a.m. for your conference, so
thank you. Wait, isn't it?
um,
Isn't it? It's it. Oh, it is at 5 a.m., isn't it?
yeah,
Oh, I'm sorry.
that's
I
okay.
think we're gonna have if we have the next one, whenever we have it, is gonna be at like uh 8 or 9 in the morning European time, so that it's at
Yeah.
least 8 or 9 p.m. Oceania time.
Does that work out better or worse for the US, who are halfway
Oh, it
between?
would it would it would be worse for the U.S. It'd be middle of the night for the U.S. So the idea was to be 12 hours offset the other way, so that we get
Right. Yeah.
Europe
So
and Asia Pacific, where like this conference we've gotten Europe and the U.S.
yeah.
intentionally. Like it's 5 p.m. Berlin time and it's 9 a.m. California time. So literally, like it's spreading Europe and the U.S. The idea is to do like 8 hours offset in the other direction, so that we spread Asia, Pacific, and Europe. And then, sorry,
Yeah.
U.S.
That makes sense.
You're less invited on the next one. But if you want to wake up at 5 a.m., you're welcome to. Or I guess I don't know. Yeah,
Before then, yeah. Um, yeah, sounds like a pretty good approach. You could even go like +8 every time,
but then I have
cruise
to be up at
around.
4 a.m. some point.
Oh, yeah.
You organize the conference, you get to set the time.
That's the pack. And there was one. Um, so yeah, the last thing I've been wondering about is on that futures front, if whether there's a way to do futures without necessarily needing futures. So want to be able to encode state in the API without it needing to be exposed. Want to be able to execute this asynchronously or synchronously. Don't want to use boxing or anything else. And the only thing I've come up with so far that I think might be viable is this approach. It turns out you can put bounds on associated types and traits. And if you put a feature bound on there, then the type that implements that has to have a feature. So we can all of a sudden the like asynchronous pollable feature objects that I had at the sort of generic level become driver specific, but they can actually have the sort of relevant state machines and everything else in. And I'm wondering if maybe this is a model that could work for our async HAL traits and things as well. Obviously, I need to actually explore it a bit more. But there's no executor specific anything involved. There's nothing unstable. And if you want to execute this synchronously, you just got to poll on it, which is functionally pretty much the same as any other approach. You've muted yourself again.
So I'll be very. I realize. So like the one thing I don't like about this chat is it keeps like randomly picking whoever the last person who chatted, and so like I just respond to them and all panelists. So like I keep having to repeat myself and selecting everyone. So like I that's annoying, and I got to figure out how to turn that off. But I know almost nothing about async in Rust. I've tried unsuccessfully to learn multiple times, and I'm looking very much forward to learning how to do this. I know that futures are a thing. I didn't realize you can do this. This does seem like an interesting way to bind on traits that have to return future methods. I did not know you could do that, but that like looking at that does make sense. I wonder. You should send me that gist, and I will send it to the Ferris people, specifically Jonas and Jorge, who are working on async embedded stuff, and see if this is actually a thing that helps them. Or is it in the?
All of the stuff and the issues are in that Dropbox paper link that I sent you. There's a playground link. It's the proposed async radio traits.
Yeah.
But yeah, it's just kind of interesting from a like binding a type without needing to box it or have impl trait in a trait, which obviously we don't yet have.
Yeah, I don't know the difference between what impl trait would offer that isn't this. Whether it's just desugaring this, where like you don't have to put the associated trait bound, like are the associated type bound on there?
Yeah,
Like
so
what?
you could drop you could drop the associated type bound because it would be in the import, but also you wouldn't know what the object coming out the other side was. Whereas in this way the types that's returned is still concrete.
Oh, that's true. Okay, yeah. So you could you
Which
put a
has
bound that
advantages
was
and
like
disadvantages.
could you have like the output equals impl? Or I guess right now your future is impl future because the future is a trait, so it's implicitly impl future. So you are using oh no, it's still monomorphized because it's impl future.
Yeah, it's just what you can construct it over that gets limited rather
Is
than.
is this something that would run into problems if you were chaining multiple methods together because you would have different concrete types? Like 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 if you were trying to use like chained future operations where because like you have your receive future gets monomorphized to a specific type,
Yeah.
like type
Well,
A.
it is a specific type
It is a
in
specific,
this
yeah, it's not,
instance.
well, I mean, it's not, it's impl future. So your trait is an inspecific type, or it's generic over anything that implements future.
Right.
Or am I
But
reading that wrong?
if I added a static bound there, then
Yeah.
receive future has to be a concrete type that also has to implement a feature matching this, right? So at this, you couldn't return a box.
No, but what I guess what I'm saying is like it's not using dynamic dispatch here.
No, no.
It's using static dispatch, which means you do monomorphize your types, or like it is a concrete type bound. Like this
Yeah, it is.
calls to this are monomorphized for the specific type that you call them with.
Yeah.
So I'm wondering if this would be difficult to use
With
one
future
step.
chaining.
Yeah, I like what might be interesting is having a function where you create something that impls one of these traits, two different things that impl this trait, and then call like a filter or some kind. I'm admitting that I know very little about async, but I wonder if you are going to run into like the super complicated. Well, I guess you are always going to run into the super complicated life or
I don't think
type.
it's a problem because of the generators now, because you just dial a weight on it and the generator takes care of like putting together an object that stores all of the different types that you have. So you really only have to worry about the returned bits and pieces. So I'm hopeful that this is going to work. Anyway, I just thought it might be interesting to talk about in case you had any opinions.
You grabbed the wrong Ferris person for this. I'm literally probably the least knowledgeable of async at the entire company, and we've already lost Florian, we lost Jonas. So you literally, I'm sorry, you've opted into the worst Ferris employee for this, but
Still
I
good.
am interested, like particularly because like, do you have an NRF52 anything in your home or office?
Yeah, I do.
Because we have like that's the environment. Like it still requires a custom fork of Rust-C, although I think the last PR has been merged now, or is being merged, or has been accepted. Because I know Jonas said it's happening. Oh, let me pull up use generics. Okay, it's been approved. So PR 69033, which is use generator resume arguments in async await lowering, which means that you no longer need thread local storage, which means you can now implement async await on embedded. Like
so I've just been using one of the dirty thread local storage hacks for that actually. So that's already all right. But obviously this is a better solution.
Yeah. Oh, I was just gonna say, like, it'd be interesting to use those traits and play around with them. Like, I don't know if you're already using those traits for anything, but like, it'd be interesting to see what breaks them. You know what I mean?
Yeah.
I don't know how
I'm gonna have
actively
a
you're
go at
using this.
implementing them. Well, this is just me thinking about it recently. So I'm gonna go re-implement them or implement, basically replace the synchronous traits that I've currently got with these is the plan, and a little bit of sugar to support running them from a synchronous context, if you want.
Like a block on, basically.
Pretty much, yeah.
Nice.
Because that should be reasonably easy, and then see how they fall out. And because I'm already using the other version of them, or another version of async traits to do this, any sort of regression in usability should hopefully just fall out.
Yeah. That's awesome. If you already have a sync version, like doing a clean reimplementation with async is probably a good way to like stress test that.
Well, I even already have an async version, right?
Oh,
This
right. It's
generic
just with
simple one.
nice.
So I've got all of it to try against.
Very cool.
Hmm.
Okay, well, I think we will end with me not knowing anything about async, and I very much hope that we have something that can be played. Although I guess you already have something to play with, but for someone like me who
Way too
is
many
much,
things to play with.
yeah, yeah. You're sitting. This is my. We never mentioned my very cluttered office where you can't even see like the electronics section is over here where it's too close to frame to actually see. But yeah, I have a lot of boards and things to play with. But yeah, thank you so much for helping me test Zoom and also just generally chatting about stuff. I feel like I should have more of these chats that people can come and watch and talk about, and maybe we'll have more than one guest next time so we can also go back and forth on a couple things. But and thank you to everyone, all 11 people who stuck around. I feel like we got up to 18 as a max. So thank you for all the 11 of you who did stick around all the way to the end. Hope that was interesting, and thanks for trying out the chat. If you have any feedback, send me a message in Matrix or on Twitter or something like that. Let me know if like the audio was bad or the video was bad, or you saw some feature that you would like to see. But otherwise, thanks for being here. Thanks for helping me test this, and thanks Ryan for waking up vaguely early, I believe, and chatting with me for a long time.
Yeah, thanks for the invitation. It was nice to catch up again.
Yeah. All right. Well, I will talk to you soon. And if anyone else is interested, I'm gonna do this again sometime tomorrow with Tony Arcieri from Occlusion, who's been working on all kinds of cryptographic embedded things, and will be speaking at Oxidized 1K on Friday. But we're gonna try really hard to avoid everything to do with the topic that he's talked about. But I know he's been working on a couple other interesting things, so we'll probably talk about those instead. But thank you, everyone. To everyone who it's late, have a good night, and everyone else, have a great day. All right. See y'all later.
Yeah.